Okay, hello there everyone. Today I'm going to be talking about conjugates and the conjugates of a complex number. This is a very simple topic and it should be very easy for me to explain. So a conjugate, so let's look at a conjugate is basically when you turn a plus bi into a minus bi. So let me elaborate on this. If we have a complex number of a plus bi, and we're going to call this complex number z, well, the conjugate of z is going to equal a minus bi. So the real part, which is the a, stays the same, but the imaginary part, which is the bi part, that becomes minus. And there's a special notation that we can use for conjugates, and the special notation is a star symbol. So z equals a plus bi, but z star is the conjugate, and z star equals a minus bi. Now this is a concept that we can use in maths for complex numbers, as if we see an equation where we have a complex number divided by a complex number, so we have 5 plus 2i over 3 plus 4i. We want to simplify this as we don't want a complex number on the bottom, so we're going to have to rationalize the denominator. And when you rationalize the denominator of a third, you have, let's say, 3 plus 2 root 2 over 3 plus root 5. To rationalize it, you do times that by 3 minus root 5 over 3 minus root 5. And the 3 minus root 5, when that's times by the 3 plus root 5, the roots should cancel out, as root 5 times root 5 is 5, and that should work. And it's the same for this, as if we remember, I is the same as root minus 1. So we should treat I like it's a third. So we should rationalize the denominator, and we're going to treat, so the way we rationalize it is by timesing it by the conjugate. And as we know from before, the conjugate is a minus bi. So we have 3 minus 4i over 3 minus 4i. And by doing this, we can see that by doing 3 minus 4i times 3 plus 4i, we can cancel out the 4i part, as let's see what happens. So 5 plus 2i times 3 minus 4i, that gives us 15. So first, then outers, which is 20i, then the inners, which is plus 6i, and then the last, which is minus 8i squared, and this is all over 9 plus 12i minus 12i minus 16i squared. Now we can see straight away that the 12i minus 12i, those two cancel out. And then we can see that we have an I squared. Now you're probably wondering what's an I squared, what is I squared? But if you remember, I equals root 1 minus root minus 1, so I squared equals minus 1. So we can change this. So minus 8i squared becomes minus 8 times minus 1, which is plus 8. Minus 16 times minus 1 is plus 16. So now we've got a simpler equation to look at. And this was all because we used the conjugate over here. And this has helped us solve this equation. Now obviously we can simplify this down further, and I will do that now. So we have 15 plus 8, which gives us 23. And then we have minus 20i plus 6i, which gives us minus 14i. And then on the bottom, we have 9 plus 16, which gives us 25. And this is our final answer, Remember, all we're trying to do is get rid of the complex numbers on the bottom, and this is what we've done. We've now put the equation in the form of a plus bi, and if you want to be more precise, minus 14i over 25. So a is 23 over 25, and b equals minus 14 over 25. So this isn't really that simple. I haven't really simplified it. I haven't used very nice numbers, but that doesn't really matter. We've got the point across that when we want to rationalize the denominator of complex numbers, and we do that by timesing it by the conjugate over the conjugate. So that was just a cool thing I wanted to show you. So I hope you enjoyed this video. Please like and subscribe for more videos like this. I'm going to be making more videos on complex numbers, and as I've teased before, I will eventually get to the famous equation e to the a+bi equals, I think I made yeah, something like that. I can't remember what the equation is myself, but I'm going to get to that equation someday. I'm going to do some cool stuff with complex numbers, but for now I'm just teaching you the basics. So thank you for watching, and remember, maths is the way.